Hi, this is Brandon, and me and my team will be representing the Boeing Electric Aircraft Redesign Group. So essentially what Boeing challenged us to do was to redesign one of their aircrafts, the Boeing 247 legacy aircraft. They wanted us to decrease the fossil fuel emissions of this aircraft and have a comparable useful payload compared to the original design. This aircraft had to fly a total of 2,550 miles with a 30-minute reserve, and had to take off in less than 3,000 feet with no less than 100 feet per minute climb rate. And indeed, our aircraft design was a two electric motor system in unison with hydrogen fuel cells in order to optimize the flight time. And through our design, we reduced the fuel consumption at takeoff, and we're also able to fly the aircraft further distances.
During the takeoff and climb phase of the flight, 350 kilowatts of power would be drawn from the hydrogen fuel cells, and 210 kilowatts of power would be drawn from the battery pack to create a total of 560 kilowatts. During the cruise phase, the batteries would be turned off, and the 350 kilowatts from the fuel cells would be used to sustain the cruising altitude. These values were taken from the original design, and since our design weighs less, as you'll see on the next slide, these values are sufficient for the redesign. We decided to use the Cummins HG45 fuel cells for the hydrogen fuel cells, and they provide a continuous power of 45 kilowatts and can be combined to create a greater output. So we combined 8 of them to get the 350 kilowatts needed.
We choose to use two Magni 250 engine. It has the same power output as the Wasp, but it has much lighter weight. And for the battery pack, we choose to use 1,088 totals. And this battery pack used to help taking off and climb.
So we had to calculate the amount of compressed hydrogen gas that would be needed. We used the following calculations to determine that. For a 14-hour flight, 17,640 megajoules were needed. 1,058 gallons of compressed hydrogen gas will be needed, and that will weigh a total of 283 kilograms. We also ran a waterfall weight report to see how much weight we saved. In total, we saved 3,879 pounds compared to the original aircraft. And to verify our flight, we used X-Plane to run a 2,550-mile flight. We verified the takeoff and fuel requirements and also adjusted the weight and power. Thank you for listening to our presentation about our Capstone project this semester.